Hello, in this video I'm going to talk about exponential function. Alright, what is exponential function? Exponential function is defined to be fx equals to a to the power of x, where a must be greater than 1. Yes, a is supposed to be greater than 0, right? Greater than 0. And I'm going to change the range so that a will be greater than 1. Alright, means any value here that are greater than 0, for example 1 over 2 or 1 over 4, I will change it to become a number that greater than 1. It's easy for me to talk about the graph when the value of a is greater than 1. Yes, it's supposed to be a greater than 0. But any number is between 0 and 1, I will convert it to become a number greater than 1. Alright? Okay, I will talk about this later. This will be easy for me to sketch the graph if I let the a to be greater than 1, right? It can be 1.1, 2, 3, okay, any number that greater than 1. So the graph when a greater than 1 for fx equals to ax, the graph will be look like this way. The graph will be look like, let's say it will be look like this way. So where the graph of y equals to ax, intersect the y-axis, so intersect the y-axis means x equals to 0. So when x equals to 0, a to the power of 0, right? A to the power of 0 is 1, right? Is 1. So, and the horizon, and this curve will not touch the line x, the x-axis. It won't intercept the line, the x-axis, because y-axis tell you y equals to 0, right? And ax is always a positive number. Ax is always greater than 0. You must understand mathematics that a number that are positive, when the power of any values is always greater than 0, right? It means that it's always above the axis, which is will not be 0. Alright, any number power of a number, any number that are positive, power of any number will not be 0. Alright, that's why the curve will not touch the x-axis. Alright, and that's why I want to explain the characteristic of the graph, right? So as the value of x increase, right? As the value of x increase, for example, I choose the a to be 2 to the power of x, right? 2 to the power of x. So when x equals to 0, it will be 2 power of 0, which is 1, right? X is 0, it will be 2 to the power of 0, which is 1. So when x equals to 1, it will be 2 power of 1, which you're getting 2, right? Okay, it will be bigger than this number, 2. Okay, for a 1, here will be 2. So when you set x to the power of 2, then it will be 2 to the power of 2, right? Which will be 4. And you set x equals to 3 and 2 to the power of 3, it will getting 8, right? So the number getting bigger and bigger, right? 3, it become 8 exponentially, right? Can you see that? They will increase exponentially. It means that when the number getting bigger and bigger, the curve is getting higher and higher, right? Higher and higher. So, but go to the other way. When you have x equals to -1, means after 0 before -1, negative. I choose some point here to tell you the property, and so that you can think further if you're interested about this. So when you have x equals to -1, your 2 to the power of -1 is 1 over 2, right? 1 over 2 is smaller than 1, so they go lower. So when you set x equals to -2 here, you will have 2 to the power of -2. 2 to the power of -2, you will have 1 over 4. Which is much smaller. So if you set x to the power of -3, 2 power of -3 is 1 over 8, which is getting smaller and smaller. Getting smaller and smaller. And this one getting bigger and bigger, right? That's why you see the graph go exponentially high, and this one go lower, but it won't reach 0. It's just getting nearer to 0. Means that as x approaching -infinity, the negative infinity means that the value of x getting more negative, the 2 to the power of x getting nearer to 0, but will never equal to 0. This will never equal to 0. Alright? But it's get nearer to 0. The y, right? The y. That's why you see y equals to 0. They get nearer equals to y equals to 0. Right? So this is the properties of the exponential graph. That's why it's look like this shape, right? So let's move on. So how about if you have a graph that have fx equals to a to the power of negative x? We talk about the theory first, the concept here. So let's say you have a curve which have a power of negative x and a is greater than 1. Alright? It can be 2, 3, 4, 1.1. Alright? So the curve will be look in this way. The curve will be in this way. So the intercept here, when a to the power of 0 will be still 1. But this one will be different, right? This one will be different. So as the number getting more negative, it will getting more positive here. Okay, I hope you understand what I mean. As the number getting negative, you try to see if this is negative 1. For example, this is 2 to the power of negative x. For example, your fx is 2 to the power of negative x. So as the number getting negative 1 for x, it will become 2, right? Become 2. So it means the negative for making this to be positive. So negative 2, you have positive 2, 2 power 4. So it means when you go to the negative side, the graph will be getting higher and higher. Alright, higher and higher. So how about this? 1, 2, 3, right? So when you x is 1, here will be 2 to the power of negative 1. Right? When x is 2, 2 to the power of negative 2. Getting smaller and smaller. Right? You see these two, the difference between these two. Alright? Because of the power of x here and the power of negative x here. Right? So another property here is, what happens if I put a negative in front of a power of x? A power of x supposed to be always positive. Always positive, right? So once you put a negative for a number that always positive, it turns to be always negative, right? So then you look at the graph. What happened to the graph, right? The graph will show you. You see all the value of y here is positive because they're always positive, right? So once you put a negative, the graph will be reflected about the x-axis. It's turned to be always negative. Always negative and intersect the negative 1 here, right? So it's always negative. Same thing happened for this. So if you have fx equals to negative a to the power of negative x, where a greater than 1, now we look at this graph, because it's supposed to be positive a to the power of negative x. A power of negative x also always greater than 0. Always positive. 2 power of anything. Substitute any value of x. Either they are negative or they are positive. It always turns to be a positive number. So, but once you put negative, it always will be a negative. So, means the graph will be go down, will be below the x-axis, and if reflected about the x-axis, so negative 1 here. So this will be the graph. This is a 4 basic graph for exponential function. Alright, so I will go detail for this, how to sketch the exponential function in the next video.